We start with the terms element, compound, atom, and molecule. Seems simple enough, but let's just go back and make sure we're using the terms correctly. When we think about pure substances, we think of them either as elements or compounds. The definition of a compound is easy. It simply contains more than one element. But there are two common definitions of elements. The one that we will use is: an element is a substance where the nuclei of all the atoms have the same number of protons. We used this definition before when talking about isotopes. Often you will hear that an element is a substance that can't be broken down into simpler substances. There is some ambiguity in that definition. Take, for example, the element oxygen. In the atmosphere, it can exist as ozone, O3, dioxygen, O2, or oxygen atoms. On the Earth's surface, the simplest way to isolate oxygen is to get O2 from the air. O atoms, on the other hand, are very reactive and hard to isolate. But are O atoms a simpler substance than O2? By the first definition, these are all different forms of the element oxygen. This is the definition that we will use in this course. Some would prefer to use the term elementary substances when referring to elements as they exist in nature as materials. Some elements, such as helium that you would find in a balloon in the store, exist as atoms in the gas phase. The oxygen that we breathe consists of dioxygen molecules. Other elements, like iron or carbon, exist as extended structures in the solid phase, where there are a series of atoms in multiple dimensions that are bonded to each other. Notice that when we write formulas with states of matter, we are describing materials that we can handle. Going back to our first pillar of chemistry, the symbols we write can refer to individual atoms and molecules, or with states of matter can refer to materials that we can handle. Let's take a minute to think about the differences between an atom, a molecule, and an ion. Atoms and molecules are neutral entities, whereas an ion is charged. When we look at chemical formulas, an atom is given a single symbol from the element, such as O for an oxygen atom or Fe for an iron atom. A molecule exists where there is more than one atom bonded together. Molecules can be elements where all of the atoms are the same, such as in O2, or they can be compounds like CO2, where there is more than one element present. Ions can be either monoatomic, from one atom, like the oxide ion, O2-, or polyatomic, like the nitrite ion that has two oxygen atoms bonded to a nitrogen atom with an overall 1- charge. Notice that the presence of a charge automatically makes them ions. We want to take the idea of compounds one step further. When we look at the smallest unit of a compound, it may be a molecule, like in the case of water. There are individual molecules present, each with two hydrogen atoms and one oxygen atom. Alternatively, the smallest unit may be a combination of ions like sodium chloride, NaCl. We categorize these two types of compounds as covalent compounds and ionic compounds. How do we know if a compound is a covalent compound or an ionic compound? We can identify covalent compounds as combinations of more than one nonmetal. If we have a combination of a metal and a nonmetal, we can identify the compound as an ionic compound. Some people refer to covalent compounds as molecular compounds. Our textbook uses the terms covalent and ionic to describe the types of bonding present in the units. In water, two hydrogen atoms are covalently bonded to an oxygen atom. In sodium chloride, the ions are held together by ionic bonds. The differences in bonding is a theme we will explore in much greater detail in subsequent modules. In this module, we will focus on ions and ionic compounds.